I would like to start the discussion. And first of all, I mean, I'm again impressed by the research, because it's again extremely pertinent for the discussions we are having in Brussels. So we just recently had the Affordable Energy Action Plan, and upcoming in Brussels is a big work on grids by the European Commission, and also a white paper that discusses the electricity sector future more broadly. And electrification is on everybody's mind. So we have a lot of discussions in town about how to push forward with electrification. There is a significant worry by especially the electricity industry that they are now building all their grids and that they are building all their supply infrastructure without having the demand side in place, and therefore kind of seeing a lot of sunk capital around. And therefore, I think it was very, very helpful to have your two very complementary, so from the demand side and supply side, presentations here. I would like to discuss two topics. So the first topic is a bit on robustness and trade-offs, and the second topic is on what is on everybody's mind in Brussels is prices, which I haven't heard much so far. So on robustness and trade-offs, a lot of what you said sounded still that we know a bit what an optimal system should look like, and my impression is I have huge uncertainties, because there are still a lot of technologies and technological options on the electricity side out there. So I can think of a very decentralized system, and I still can think of a very centralized electricity system. I can think of having molecules more than you did in your analysis. And on flexibility sources, I mean, you highlighted how many different flexibility sources there are. So we can essentially shape our generation mix in a way with more nuclear or a mix of solar and wind in order to have less flexibility needs. We can build up a grid massively. We can build peaker plants of different technologies. We can have batteries. On the demand side, we can kind of shape structurally how our demand side looks like, also geographically, or we can shape the behavior of the demand side with, for example, electric vehicle charging. So for me, it is very hard to see what an efficient mix is going to look like, and whether there are any trigger points in terms of cost ratios between individual technologies or availabilities that might potentially still lead us to completely different systems. So the question that I want to ask to you, and maybe you can come in a bit more from the supply side and you can come in a bit more from the demand side, is in your modeling, in your analysis, do you think we have a relatively robust view of the future, or are there still significant trigger points such as the ones that I described that might lead us to significantly different systems? And maybe Sarah, you can start.
So in some of our analysis, we were actually looking at the different scenarios that we usually look at with the 10-year network development plans. So you were mentioning these two very different scenarios of which I identify with global ambition, right? So we have global ambition where we would have the renewables. So we see very clearly that renewables and electrification are the way, but then the details can be very different depending on how things develop on the demand side, or what is the political decision that is finally taken. So we could have something more similar to global ambition with very large centralized renewables. We could have the national trend scenario. We could have something like the distributed energy scenario, where that PV will not be large plants, but solar PV in rooftops. So what we have done is that we've looked across scenarios. Sometimes we have picked. So for instance, some of the analyses that were done for flexibility, they were focused on the distributed energy scenario, just because we thought that that would lead to a higher need And then when we needed to choose, we focused on that one. So we do believe that there's still some room for deciding how this electrification is going to take place and how renewables are going to be installed. It's just that there are some points that are robust, such as the importance of solar PV and wind.
And maybe on the flexibility side, because I think we already saw that before, that solar and wind seems to be the way forward. I mean, we have maybe the mix of the two, and in different countries might differ a bit. But on the flexibility side, can you say? I mean, it was quite fascinating to see how different the German and the Spanish results looked like, with Germany using a lot of hydrogen. Maybe you can say one word on where this difference comes from in your view, and then I would be interested on kind of describing it in kind of a bit picturesque, like how high is the mountain of the optimum? So are we having a very flat thing so that we can very easily switch from one solution and the other solution, and they are all very close to a joint optimum? Or is there are there different peaks, or is there one peak where we say, okay, that is kind of the mountain that we should strive for?
Okay, so the source of the difference in flexibility is the shares of PV versus wind. So when we have more wind, then the profile is more flat with respect to the time horizon. And when we have more solar, then we have a lot of need in the hourly range within the day, and there's also an increase in the yearly one. But mostly what happens is in the very short term. So the flexibility
share was exogenous. So the wind solar ratio
No,
was put in from the outside.
So the share of solar or wind, it was determined by cost optimization for the system. I think it was with one of Fraunhofer's models. I think it was from Enertile. And it takes into account the renewable potentials with a very small range, and the most cost optimal way was to use far more PV in Spain than it was used in Germany, as it makes sense. So the source of that difference in the profiles is the difference between solar PV and wind. And then you were asking one super interesting question on the shape of the optimal. And actually, like we are working, like several of us are working on related questions on how to identify the main factors that lead to an optimal solution in a problem, or in my case, I'm trying to study the quasi-optimal solutions of these problems, because it's not about just the optimal, but as you were saying, the region around the optimal. Still, I don't believe that that it would be super easy to give an answer. There are some publications from people around, like some of Will's publications, where there are some analysis of global sensitivity analysis of the landscape. It seems like, in any case, so this is an impression, but more research should be conducted in this, and this is fascinating research. The impression is that these sort of problems are kind of degenerate, in the sense that you move a little bit more PV, a little bit less PV, is not going to kill you in any case, and this is very good. Another related problem that I have studied a lot in these terms is the expansion of the network. So in the expansion of the network, and we could see that we are going to need quite a bit of network. So the expansion of the network, when you analyze the solutions, it's terribly degenerate. So there are many different ways in which you will reach an optimal solution that is super similar. This is good because it makes us feel comfortable. However, I do think that this should lead us to more modeling efforts in the future focused on these quasi-optimal solutions, because even though they might be very similar in terms of overall cost, they might be very different in terms of impact in different communities or on other objectives. So I think that in ECMF, we've made a great project taking many different models, combining them, high level, low level, everything. And the next step could be to analyze this similar quasi-optimal paths so that we can make the most of this degeneracy that exists in the problems.
Yes, thanks, Sarah. So it's I agree. It's a fascinating area to kind of understand, is economics trumping everything we can determine an optimum and then everybody has to just do it, or whether the whole result that we get is a rounding error, and then other kind of considerations become much more important. Lucas, on the back a bit to the initial question. So, are there triggering points also in the assumptions for the type of results that you are getting? How robust is what you showed us?
Yes, thanks for this question. Of course, there are uncertainties. I think that one of the, or let's say the first group of uncertainties that I would see is how far is it possible by efficiency measures, let's say non-electrification related efficiency measures, reduce the demand. Because every kilowatt hour that we will not save will then finally increase also then electricity demand, and with the related impact on the electricity system. So I think that's an important question, both from the, let's say, the technology uptake point of view. So what about let's say modal shifts in the transport sector? What about building renovation uptake? But then also about what about rebound effects? No, both on the macro level and the micro level. So how will people really respond? So we try to factor that in. So most models include somehow or have some assumptions at least regarding rebound effects. But I see some uncertainties here also. So I think in the past we saw often that efficiency measures simply led to higher demand for energy services, and that's a risk, I would say. Yes, so that both technological wise, but also behavior wise, let's say, to which extent efficiency potentials can really be exploited. That's one uncertainty. You also asked about, let's say, whether we couldn't also imagine futures with higher share of molecules. Yes, I mean, what I did not show because of the limited time for the presentation was that we had a model iteration with a full system model, first providing us with an initial set of prices. With that, we went to the sectoral models, and then we went back to the full system models to see what it means, and then again back to the sectoral models. And the point was that the initial prices had lower hydrogen prices. And with these lower hydrogen prices in some sectors, in particular in transport, we saw a bit higher demand. With this, after the, let's say, feedback loop, after the reduced prices, we saw that this demand reduced in transport. In buildings, we anyway don't really see it much unless we push it strongly into the models, let's say. But it doesn't really turn out to be economically viable. And in industry, the sensitivity was the lowest because there, where it is used, it's also needed, let's say. Yeah? So that was at least our experience from this modeling exercise.
So there aren't any, you at least don't see any big surprises that are left out there, that maybe CCS picks up a big time and we can do some of the industrial decarbonization without electricity, or.
No, I mean, I think hydrogen prices are, of course, also an uncertainty, but I would. So my perspective on that is, because they are uncertain, we should also be careful in where to apply hydrogen, because otherwise we end up with a solution. For example, in the building sector, of course, we could think of a future where we have hydrogen also in heating systems, but then once we have built this system, it would be super inert, and it would take a long time and huge investments to go back again from them. And if we would end up with higher hydrogen prices, and if the space heating demand would be based on hydrogen, then the likelihood is higher than that we end up with higher hydrogen prices. Then we simply are locked in this expensive system.
Good. Then I think we have 10 minutes left. I would have one kind of big question, and then I would like to give it to the audience. So the question is on prices. Now that's kind of everybody is interested in that, and I haven't seen much in any presentation. Is there any hope that electricity prices in Europe in the course of the transition will become substantially lower than they are today, or is essentially with the system that we are now transforming to, we are relatively close to where we also be where we will also be in the long term? And I'm talking about kind of long-term average electricity prices, not marginal prices, which I understand will be quite volatile. So did you have some results on that in the
So I'm afraid that I cannot share a lot. The only thing that I can share is that this the impact that gas prices will still be here with us, at least for the medium term. So we should expect to remain with volatile prices in the next few years. For 2050, then things will be very different. For 2040, 2050, of course, this will, but in the transition, volatility due to gas prices is here to stay.
So any indication on the amount of hours where you're saying that gas will still be marginal, for example, in Spain?
Not from the top of my mind, sorry.
I mean,
not a lot, but
I mean, what I'm wondering is then you mentioned the massive amount of flexibility that we are getting or have to get into the system, and at some moment I wonder whether that will look like a much smoother supply curve and also a much more elastic demand curve, so that prices are essentially not formed anymore. Also, the marginal prices are not formed anymore at the kind of gas price level, but are formed somewhere in between the gas price level and the lower level, because there is this anticipatory kind of pricing of electricity.
Things that as we completely get rid of the gas with the marginal market, it will impact the price. So even if the amount of power produced is very low, we still have that feature in the market.
Okay.
Yeah, I mean, from the sectoral demand perspective, we use the prices as exogenous input. And what I know, but I don't know whether Robert, you want to add some on that, is that indeed, I mean, electricity prices are much lower than, let's say, or at least in most of the results that I saw, and also the price scenarios that we used, electricity prices are lower than hydrogen prices, for example. No? And I think that's what triggers a lot. Yeah, and probably also, yeah, the question of this relationship of electricity prices and hydrogen prices, what you've shown regarding what is the role of the different flexibility options, no? And to which extent is hydrogen being really produced at hours with very low electricity prices, or whether there are other flexibility options in place, not making that feasible and possible. And overall, that electricity prices also were, yeah, as you said, in a comparable range to what we see now. I don't know.
Maybe briefly chiming in here. Clearly on prices, we do see quite some uncertainty across the models. What we also, or like few robust things, are that we don't go back to this sort of unnaturally low period, 2005 to 2015, where we had huge capacity oversupply, so that the power system Europe functioned on a pure marginal pricing basis, where there was no, or many companies got into difficulties because they couldn't repay their investments because there was so much oversupply that never scarcity hours came up. So this is not a situation we are likely to go back into for a standard period. But we expect to go down a bit from the levels we've observed over the last 4 years on average. I mean, clearly the peaks in 2022, those should not be repeated on a multi-level basis, and will also go down a bit as you say, the role of gas is reduced, and you have a lot more time where you are in this intermediate range where your actually flexibility from the demand side will set your prices. There is uncertainty on that, but it looks like it comes down. And what is important to keep in mind, the final energy prices that you pay are pretty far away from your wholesale market prices. I mean, for residential customers, for surely you have roughly 100% increase in most of the EU member states because of tariffs and fees and so on. But also for industry prices, how much of the grid fees are put where and how are they put? So this will have a huge impact. Clearly, it won't, like, we won't have final energy prices to the level that some super renewable rich countries, Australia or North Africa, will have. That is out of question.
Thanks. So that was very very helpful also in terms of the uncertainty alluded to. And yeah, we're also at Bruegel currently thinking about where to put then the increasing share of fixed cost of the system, so whether one can shift it around. And I mean, policymakers always hope that if they can shift it around 20 times, then it disappears, which unfortunately is not the case.